Hello students, welcome back once again to my YouTube class. As you have learnt regarding sound in my previous class, the sound is produced by the to and fro motions of an object and the different characteristics regarding the sounds. Today in this class you will learn how sound travels. Students, as you know, sound is produced by the vibration of different objects. When we hit any object, what happens? Some vibrations are produced, and because of the vibrations or the to and fro motion of the object, the sound is produced. But how is it possible that this sound is able to travel to a distance? Depending on the loudness or the amplitude, the sound travels to different distances. When sounds are produced by the vibrating body, we get a form of energy, and this energy, it gets transferred to the surrounding air molecules. Okay, and with the same frequency, when the air molecule starts vibrating, what happens? The sound travels to certain distances. So for letting sound to travel to a certain distance, a medium is required, and the medium that sound requires is nothing but the air medium. We know that at the time when we produce any sound, what happens is that the sound is surrounded by air molecules, and because of the vibrations that are produced, the air molecules also starts vibrating and leads to the transfer of the sound. If we get no air molecules surrounding the vibrating object, then what will happen? The sound will not travel at all. For example, you can do one activity, taking an empty jar. Okay, by closing the empty jar with a stopper, if you take one radio, okay, and insert it inside the empty jar and close the stopper of the empty jar and try to listen the sound produced by the radio, you will not be able to listen, because an empty jar doesn't allow the surrounding air molecules to vibrate and move outwards. So as a result, we fail to listen any sound that is produced by the radio. Okay, so from this activity we can understand one thing, that is the sound is produced only by the vibrating air molecules. Now talking about the speed of sound, if we talk about the speed of sound, we know that light also has speed. So if you compare light and speed, light travels faster than sound. It travels at a speed of 3 lakh kilometers per second. This light, it travels at a speed of 3 lakh kilometers per second, whereas sound travels at a speed of about 340 meters per second. So sound travels much slower as compared to the light. Okay, that is why at the times when there is heavy rainfall taking place, especially at night, we happen to see the lightning as well as the thundering, hear the thundering of the cloud. So we are able to see the light at first with the accompanying sound of thunder, because light travels faster than sound. Sound also carries much faster than through liquids and solids than through air. Okay, so to allow sound to travel, what happens? We require a medium, and based on the medium, what happens is that sound also travels faster in case of liquids and solids than through air. Moreover, sounds are clearer and louder. Okay, that is when the amplitude is greater when heard through liquids or solids rather than through air. This is the reason why whales can communicate each other over even hundreds of kilometers. We know whales, they are always found on water. They are able to communicate with each other even they are hundreds of kilometers away from each other, because the sounds can travel faster in liquids. Now talking about telephone, you all know what is a telephone. Okay, nowadays at present in most of the houses we find people are using only mobile phones, but before the invention of these mobile phones, people were using these telephones. Okay, so you might have heard the person who has invented this telephone. It's no one but Alexander Graham Bell. Okay, it's a device that can carry sound over a distance, and people are able to communicate with each other, okay, from a distance. The earliest efforts to produce a device in which sound could be carried by electricity were made in the early 1860s, and it is made by a stretched parchment in the mouthpiece vibrating with sound. These vibrations were converted into a fluctuating electric current, which made a parchment in the receiver vibrate, and these vibrations reach the ear of the listener. Okay, so these telephones help one communicate with each other from distance because of the vibrations, okay, that are produced and transferred due to the fluctuating electric current. Now talking about how sounds are made and heard by animals. We know all higher animals, including mammals and birds, okay, they communicate with each other making sounds with the help of vocal cords. Okay, but if you talk about some of the lower animals like frogs, they have got vocal cords. Insects, they make very loud noises, though they do not have vocal cords. Crickets make a chirping noise by rubbing their wings together, while grasshoppers make a loud noise by rubbing their hind legs against their wings. If you talk about the snakes, they hiss by forcing air out of the mouth, and the humming of bees, mosquitoes and flies is caused by the vibrating of the wings. So different animals, they produce different types of sounds, okay, and they produce different types of sounds, some with the help of their vocal cords, and some even though they don't have vocal cords, but they are able to produce loud voices like the insects, as I have discussed, cricket, grasshoppers, mosquitoes, bees and all. Okay, now talking about how we speak. How we speak with a different tone. Different different organisms have got different tones to speak out. Okay, all of us, we have got different tones. We speak in different ways, but the way of communication, the language that we use is same. If we go and speak with any person, okay, throughout the world, your language may not match, but the way we speak is same to all of us. If you talk about the different animals, okay, then different animals, they talk in different ways, and the only organ which helps us to speak is called larynx. This larynx is also called as the voice box. It lies between the pharynx and the trachea. At the time when we are supposed to speak, what happens? Air gets exhaled out. The exhaled air, it passes out through the larynx, or two folds of tissue within it vibrate. That is the vocal cords. These vocal cords consists of two folds of tissue. It starts vibrating at the time when the air gets exhaled from our mouth. Okay, and because of the vibrations that are produced by the two folds of tissue known as vocal cords, the sounds are produced. Talking about how we hear, we know that we all hear with our ears. So the ear that we have, okay, we have got two ears on either sides of our head. So each ear is divided into three parts. If you look at a picture, figure 9.12, you can see that each of our ears are divided into three parts called as outer, middle and inner. The vibrations of any sound that producing body, okay, are transmitted to our ears by the vibrating molecules of the ear. These vibrations, first it reaches our outer ear. So this outer ear, it again consists of pinna, the ear canal and the eardrum. So what is pinna? Pinna is the portion of our outer ear, okay, which we can touch and feel, and Secondly, we get the ear canal, okay, which is the hole that you can see attached with a pinna, okay, and at the end we get the eardrum. When sound vibrations reach the ear molecules passes through the ear canal, start vibrating and strike a stretch membrane which is called the eardrum, and then the sound particles or the vibrating ear molecules passes through the middle ear. Inside the middle ear we find 3 delicate interlocked bones, and the 3 delicate interlocked bones that we find in the middle ear, these are named as hammer, anvil and stirrup. Okay, so at the time when the ear molecules passes through the middle ear, this hammer, anvil and stirrup, okay, all the 3 bones, they start vibrating in such a way that the bone lets the vibrations to be passed to the inner ear, and inside the inner ear we have got the main or the real organ of hearing, which is known as cochlea. It is like a coil-like structure. Inside it we get ears. This liquid filled tube with vibrations transmitted from the middle ear, and then the signal is sent to the brain through auditory nerves, and the brain then interprets us to hear the sounds. In this way we are able to hear sounds. What we do, what other animals hear. We know that we can hear sounds only within the frequency of 20 Hz and 20,000 Hz. In between 20 and 20,000 Hz we can hear the sounds, and the sounds of frequency below 20 Hz, they are called as infrasonics, and those of frequency above 20 Hz, they are called ultrasonics. We can hear sounds between 20 Hz and 20,000 Hz. We can also produce sound within a range of only 60 to 1300 Hz. The range of sounds that are produced and heard by other animals are different from those produced by and heard by us. If you talk about dogs, cats, monkeys and bats, these are some animals which can hear ultrasonics. That means the sounds that are of higher frequencies, more than 20 Hz. Dolphins, porpoises and whales, they can listen the sound of low frequencies, or what we can call as infrasonics. Okay, they can communicate with each other from a far distance. The range of sounds produced by an animal does not always match the range of sounds it can hear. In fact, some animals like snakes can make sounds though they cannot hear. Okay, snakes and some other animals, they are able to produce the sound but they are not able to hear. Now talking about what is reflection of sound. We have learned in our previous class regarding reflection of light. So same like the reflection of that takes place in case of light, okay, reflection of sound also takes place. So sound is also reflected, absorbed and transmitted to different extents by different metals. If you talk about soft porous metals like cloth, thermocol, cotton and wool, these are good absorbers and poor reflectors of sound. If you talk about hard surfaces like concrete, walls and metals, okay, these are again some good reflectors of sound. Reflection of sound, it means that echoes. These echoes are known as reflected sounds. At the time when we happen to enter an auditorium or a closed building, okay, a building in which no one we find, sometimes when we go on calling out, is there anybody, is there anybody, you are able to listen back the same sound that you have talking. So such sounds are called as reflected sounds or echoes. But why do we not hear them all the time, even though there are plenty of reflectors of sound around us? Sometimes it happens that we are not able to listen the reflected sounds or the echoes. It is because the sounds gets absorbed due to the things that are present in the surrounding medium. For example, if you want the sounds to get reflected or the echoes to listen, then there must be a time lapse of 1/15 of a second between them, or we can say the reflecting surface should be 11.3 meters away from the place where the sound is produced. There are many things which helps in reducing the reflecting sounds or the echoes. We know that in auditoriums and all, what happens if we don't have these materials that absorbs or reflects sound, okay, then what would happen? The sounds that are produced in the auditorium would create a disturbance. So most of the auditoriums, they are what? Attached, or they are again added up with some good reflectors and absorbers of sound. This has not been the case. Other voices would be reflected and re-reflected from the floors and walls, making it difficult for us to converse. Okay, we would not be able to hear distinct echoes, but there would be a disturbance. The woods, clothes, furnishings, and are poor reflectors and good absorbers of sound. So many a times we find the auditoriums are again added up with some extraordinary things, with wood, clothes, furnishings, and all. When we need to be more particular about reducing reflection in auditoriums and theaters, we use special absorbing materials to cover the walls and the ceilings. Now let us learn some of the uses of these echoes. We have learned that these echoes are reflected sounds. So how does it helps, and how do we use these echoes? It is used to locate underwater objects and measure the depth of seas and all. The vibrations that are sent down from the ships, okay, and the time taken for the reflected vibrations to return helps us calculate the depth of the object that reflects and vibrates. Even the doctors, they use these echoes to get a picture of internal organs of the body. Ultrasonic vibrations reflected by different parts of the organ helps to create an image of the organ, and the technique is called echocardiography in case of the heart. And to get a picture of internal organs of the body other than the heart is termed as ultrasonography. Even these echoes are used by bats to locate their prey. These bats, they locate their prey by emitting ultrasonic vibrations, and they are able to judge the distance of the prey from the time taken by the echo to record. Okay, such organisms other than bats we find porpoises, whales, seals, and all, to also find the way around them. So my dear students, hope you all have got the topics that I have discussed. If you have any queries, please contact me every night between 8 to 10. I shall help you. With this, your class gets over. Thank you. Have a nice day.